Let us see the physics behind opening and closing the door, and also using the wrench. Okay. Now, what happens when we close and open the door? We hold the door at the handle, and then the door sweeps an angle or makes a semicircle with the hinges as the axis of rotation or around the hinges. Okay, the door is sweeping the semicircle around the hinges. So therefore, the hinges are the axis of rotation, and then we are applying the force at the handle. Okay, so this is what happens when we open or close the door. Obviously, while opening the door is making a movement called counterclockwise movement, and then while closing the door, then what happens? It is moving in this direction. So this is, I will show you. We know the clock moves in this direction. Okay, and then this direction is called the clockwise movement. Okay, suppose if the rotation is in the clockwise direction, we call that as positive negative direction. Okay, clockwise direction as the negative. Suppose counterclockwise. Counterclockwise means it should go in this direction. Okay, or in this direction. Okay, opposite to the clock direction. That is called the counterclockwise direction. Counterclockwise direction is always positive. Suppose if the object moves in the counterclockwise direction, then we call it as positive direction. Okay. Now, coming to the wrench. Okay, or spanner. This is also called as a spanner or wrench. What happens here? We hold the spanner here, and this is the point about which the spanner makes a rotation. Okay, that is why it is called the pivot or the point of axis of rotation. Okay, point or axis of rotation. And then the line joining the pivot and the point of application of force is called the radial line. Okay, and then we will not apply the force just like this here. The angle between the point of application of force and the hinges is 90 degrees. Am I right? This angle is 90. Perfect. Okay. But whereas in the spanner or the wrench, the angle will be different. It may not be 90 degrees. It may be some other angle. Okay. According to the convenience, people will hold the wrench and then they will rotate the wrench. Okay. To tighten the bolt or to loosen the bolt. Okay. So the angle made by the force with the radial line is the height. Okay. Now we will see what is the physics behind these kind of things. Okay. Sometimes it may always you see people will hold the wrench or the spanner at the end, not at close. Okay. 99.99%. Rarely they will hold the spanner very close to the head. Okay, this one. Similarly, we try to open and close the door holding the handle, and then we keep handle as far away from the hinges as possible. Okay, so why we are doing all this kind of things? And then here also we are making an angle of 90 degrees for the door. Okay, the handle is making an angle of 90 degrees with the hinges. Am I right? See, this is the axis of rotation. So this is the point of application of force, and then the angle is 90 degrees. So to find out the answers for all these things, we will study a concept called torque. Okay, torque is written like this, tau. Okay, this is called tau. Tau is a Greek letter. Okay, so torque is represented like this. Today we will study this torque. Okay, in translatory motion, net force is required to make an object to move. Our net force is responsible for the acceleration of the object. So F is proportional to A. This is your Newton's laws, okay? Or F is equal to ma, okay? Where F is the net force, okay? And then m is the mass, and then A is the acceleration, okay? So to produce acceleration in an object, you have to apply the force. Similarly, in rotational motion means the objects or the bodies are rotating about an axis. Okay, in rotational motion, to rotate an object, a quantity called torque is required. Torque is responsible for the rotation of the object. Okay, so the torque is equal to I alpha. Similar to force F is equal to ma, torque is equal to I alpha. This is torque, and this is the rotational inertia or moment of inertia. Rotational inertia. This is also called as moment of inertia. And then this is your angular acceleration. Okay, now our aim is to find out torque. Okay, how to find out the torque? How to measure the torque? Okay, and moreover, torque is a vector quantity. Okay, therefore the direction is also important. So how to quantitatively measure the torque and then how to find out the direction is important. Okay, for that, let us see. Both with the help of these two cases, we will learn that concept. Here, what is happening? This is your R bar. R bar means the distance between the point of application of force and the axis of rotation. Okay, and then we are applying the force. So we can measure the torque like this. Torque tau is equal to R cross F bar. That means here we are taking the cross product of two vectors. You know there are two types of multiplication of vectors. No? One is the dot product, another one is the cross product. Here the two vectors are multiplied by a cross, that is what is called cross product. And then the cross product is always like this R bar, F bar, sine phi, where phi is the angle between R bar and F bar. Okay, this is the general formula. And then obviously here R is measured in meters and then force is measured in newtons. Therefore, torque is measured in torque units. Meter, Newton, R, Newton meter. And then again, the direction, because the torque is a vector quantity, torque is a vector. You know, no, cross product is a vector. Cross product of two vectors is a vector. Okay, so the torque is a vector. Therefore, the direction, we have to write the direction. Counterclockwise direction is positive, and then clockwise direction is negative. Suppose if the object rotates in a counterclockwise direction, we call the torque as positive. And then if the object rotates in a clockwise direction, then that torque is called negative. Okay, now let us see how it works. So the torque depends on three factors. One, amount of force, the magnitude of the force. And the second one is the distance between the point of application of force and the axis of rotation. Farther the point of application of force from the axis of rotation, higher the torque. Okay, and then higher the amount of force, then higher the torque. And the third one is angle between R bar and F bar. So if phi is equal to 90 degrees, sine phi is equal to 1. So torque is maximum. Suppose if R and F are maximum, then for an angle of phi, torque will be maximum. Okay. For any other angle, torque will be less than this one. Okay. Suppose if you keep R and F constant and then increase the angle up to 90 degrees, then at 90 degrees you will get the maximum torque. Okay. And then next one. So what we have to do is, for easy push and pull, or to make the door rotate easily, or to open and close the door easily, we have to keep the handle far from the hinges. That is the reason why we keep the handle far from the hinges. Okay. And then the second thing is, this hinges and handle always make 90 degrees. So hinges are in this direction, like this, and then handle is like this. If we draw the lines, they are perfectly perpendicular, so that we will get maximum rotation with minimum force. Okay. And then here also the same thing. Okay. You have to measure always the angle with respect to the radial line. So whenever you are applying the force, the angle must be measured with respect to the radial line, and it should be suppose if they give the angle like this, suppose if they give this angle theta, okay, then your phi will be 90 minus theta. Okay, that is the thing. Next, let us do one or two problems to have a good understanding of the concept. Okay, so here you see, here he gave in this problem, figure shows a force of magnitude 55 newtons is applied to a door. However, the lever arms are different in the three parts of the drawing. In the first part, L is equal to 0.8 meters. In second bit, L is equal to 0.6 meters. And then in the second bit, L is equal to 0 meters. Find the torque in each case. So first I will write the force. Here, force is equal to 55 newtons. Okay. And then phi angle is equal to 90 degrees. These two are constant. Okay. They are not changing throughout the question. So for the first bit, R or R bar is equal to 0.8. Okay, therefore, torque tau is equal to R cross F bar is equal to RF sine theta or RF sine phi is equal to 0.8 times 55 times sine 90 degrees. Okay, so this gives torque is equal to 44 Newton meter. Okay, similarly for the B bit, the rest of the things are same, only R is changing. This is equal to 0.6 meters. Therefore, torque tau is equal to 0.66 times 55 times sine 90 gives a value of 33 Newton meter. Whereas in the third bit, R bar is equal to 0. That implies tau is equal to 0. Okay, so from this problem, we can see that even though the force and the angle are same, if the distance changes, the torque will change. Okay, so we will see one more problem, simple problem, and then we will close the session. Okay, here, Ryan is trying to open a struck door. He pushes it at a point 0.75 meters from the hinges with a 240 Newton force directed 20 degrees away from being perpendicular to the door. There is a natural pivot point, the hinges. What torque does Ryan exert? How could he exert more torque? Okay, so let us take this as the hinge. Okay, and this is the radial line. And then the force is applied at an angle of 20 degrees. So he is giving this angle. This is the 20 degrees. But we need this angle. Okay, this is our phi. Okay, and then this is our force, 240 newtons. Okay, and then the distance between these two is 0.75 meters. Okay, now we have to write F bar is equal to 240 newtons, and then R bar is equal to 0.75 meters, and then phi is equal to 90 minus 20 is equal to 70 degrees. Okay, now torque tau is equal to R cross F bar, that is equal to mod R bar mod F bar sine phi. Okay, therefore tau is equal to R bar is 0.75 times force is 240 newtons times sine 70 degrees. So this gives 169.1 Newton meter. Okay. Now, what is the second bit? How could he exert more torque? So torque depends on three factors. One is angle. So instead of 70 degrees, if he is able to make it 90, then the torque will be more. The second thing is, instead of 0.75 meters, we don't know, maybe there may be a bit more of the length if possible. Then he can try to open the door, moving a bit away from the R. That means increasing R. What I mean to say is increasing R. Instead of 0.75, he is able to increase R. Then also the torque will be more. And then increasing the force. Okay. One is increasing the angle from 70 to 90 degrees. Second thing is increasing the force. Pushing or pulling the, or he is pushing, so pushing with more force. And third one is pushing away from the hinge, a bit farther from the hinge. We don't know the exact length of the door, but he is pushing at 0.75. Consider it be 1 meter length door. Then he can push it from the end so that the torque will be more. Okay, so this is how we can uh, do the problems, and this is the concept of torque. Okay, so torque is the uh, rotational equivalent of the force in, okay, torque is the rotational equivalent of the force. Hope this helps. Thank you. Bye bye.